Hey guys, all right, so I am on page 14 of the Unit 6 packet. Okay, so I'm just going to go over number 47 and number 48. Okay, so in 47, the first thing they want us to do is it says explain what the numbers 0.5 and 1.21 represent in this equation. Okay, so the 0.5, right, it doesn't actually represent a half a snowboarder, okay? The keyword, not keyword, but a key point right here is in millions, okay? So because this is in millions, this means there was a 500,000 snowboarders in January of 1988, okay? You could either write 500,000 or a 500,000, either way. It's both the same thing. But it is important to say when and what, okay? All right, and then also how many. All right, the 1.21. So we know that within the parentheses, it represents 1 plus the rate, right? So if you think about 0.21 would be the rate, because here's your 1, and then plus the rate would be this. Okay, so if you think about 0.21, if we take the decimal and move it 2 places to the right, that's equal to 21 and then percent, right? When you change from a decimal to percent, you move the decimal over twice. So what that means is that the number of snowboarders is increasing by 21% per year. Okay, so I just said 1.21 represents a growth rate in snowboarders by 21%, and it's super important to say per year because it happens every year. Okay, so now the next part of this question, let me just highlight it and do a different color. It says, find the year in which the number of snowboarders will be 10 million for the first time. Okay, so what I did was I wrote the general exponential growth formula here, and then I wrote the equation that, pertains to this problem. So we could see that P, the 0.5 is the initial snowboarders, and when I say initial, I mean in January of 1988, right? We already talked about how the rate is 21%. So this X is just representing the time, and this Y is just representing the amount of snowboarders after a certain time has passed. So when they want us to figure out during which year, right, we're solving for the X, and will the number of snowboarders be 10 million for the first time, we need to replace this, right, the amount after a certain time has passed, with the number representing 10 million. Now here's the deal. So let me erase this Y. We're not actually going to write 10 million. We're just going to write 10, because if they used 0.5, right, to represent a 500,000, right? Since it says it's in millions, 0.5 represents a 500,000. If we want to represent 10 million, we're just going to replace the left-hand side of the equation with a 10. Okay, and then just solve. So to solve this, you're going to solve it, in the same fashion that we solved the equation in number 46. So we're first going to divide by the number in front of the parentheses. We want to get rid of this. So we're going to divide both sides by 0.5. And dividing by 0.5, dividing by a half, right, is the same as multiplying by 2. So 10 divided by a half would be the same as 10 times 2. So that would give you 20. So 20 equals 1.21 to the x power. All right, so let's think about this. We're solving for an exponent. Whenever you're solving for an exponent, you want to put the word log in front of both sides of the equation. So I'm going to put log here and log here. Okay, and the reason we do that is because the power rule says you're allowed to take your power, right, and you can move it in front of the word log on the term that it's, an exponent on. All right, so we're going to have log of 20 equals x times log of 1.21. Okay, and then since this is x times, right, multiplication, the opposite of multiplication is division. So if we want to get the x by itself, we need to divide both sides by the term it's being multiplied by, which is log of 1.21. All right, so those cancel. On the right, we're left with just an x. And now this you're going to want to plug in your calculator. And when you do, you wind up getting 15 point, I'm just going to round here to 4 decimal places, 7157. Okay, so let me go back to the question. The question says, find the year. It doesn't say how many years, right? This is telling us how long it takes. We want to find the actual year. So if we were starting off by looking at these stats in the year of January 1988, what we're going to do is we're going to take that year and we're going to add on how long it takes to reach 10 million. Now, if you think about this number, this is a little tricky, right? Basically, a lot of you probably are looking at this and saying, all right, that rounds up to 16, so let me add on 16 to 1988. But if you think about this, even though this rounds up to 16, doesn't this still happen within the 15th year, right? It just happens 0.7 of the way through the year, later on in the year. Like even if this was 15.9, right? Even if it happened in December of the 15th year, doesn't it still happen within that year? Okay, so I just put this here. I mean, I just write it, you know, I want to write it out in words. You may want to do this in your notes too. Even though this rounds up to 16, it happens within the 15th year. So basically what we're doing is we're adding on 15 to 1988, not 16, okay? So then that's going to give us 2003. Okay, and then let's take a look at number 48. Okay, so in number 48, they give us this equation, right? Here we go. And we're talking about a townhouse purchased in San Francisco. It was purchased for $80,000, so that's why that's in the initial spot. You could tell by here, right? If this is 1.12, this is the 1, and then plus the rate. So the rate is 0.12. Okay, so, which is, if you move the decimal over twice, 12%. So the value of this townhouse is going up by 12% per year. Okay, and we know it's going up because remember, if this number is greater than 1, it's growth, right? Because it's 1 plus the rate. And if this number is less than 1, it would be decay because it would be 1 minus the rate. Okay, but either way, it says, let me just highlight this. In what year was the building worth double its value in 1975? Okay, so let me get this out of here because we don't actually need this. So in 1975, we know the value of the building was $80,000. We want to know in what year, so we're looking for the time, so we're looking for the T, we're going to leave that as a T, was the building worth double its value? Okay, well, if it was $80,000 in 1975, double 80,000, right? 2 times 80,000 would be 160,000. So we want to know how long does it take, right? Solve for the T, to grow to 160,000. So we're going to take that and put it in for A. All right, so here we go. So we know when we're solving for an exponent, right, we're going to have to use logs. But before we do, we have to get this base that contains the exponent on it by itself. So let's get rid of this 80,000. So since it's 80,000 times, right, that's what parentheses mean. We're going to do the opposite of multiplication. We're going to divide both sides by 80,000. Okay, so on the left-hand side of the equation, when we divide those two numbers, we get 2. And then I'm going to bring down the 1.12 to the t power. And you don't need the parentheses here, okay, because you're just taking a number and raising it to a power. All right, now this, remember when we're solving for an exponent, this is where we're going to put the word log in front of both sides of the equation. Because by doing so, the power rule tells us you could take this power, right, you could take this exponent and bring it to the front of the word log. So we have log of 2 equals t times log of 1.12. And then to get this t by itself, let's just divide both sides by log of 1.12. Okay, we're trying to get that t all by itself, get those to cancel. Okay, so basically we just have to plug this in our calculator and see what we get. So I'm getting 6.1163. Okay, so it happens within the 6th year. But they don't want to know how long. If it said how long, you know, you would round this to the nearest year, you would round this to 6 years. But it says in what year. Okay, just like the last problem. So we're going to take the year that we started looking at these stats, which was 1975. Or actually, I should say the year we purchased, right? The townhouse was purchased. And let's add on 6 years. Okay, remember, whatever the decimal is here, it still happens within the 6th year. So we're going to add on 6. And that brings us to 1981. And that's it.